Hey everyone, welcome to Tech Wired. In this video, we are going to solve problem number 958, check completeness of a binary tree. First, we'll see the explanation of the problem statement, then the logic and the code. Now let's dive into the solution. So here I have taken an example. So in this problem, we need to check the completeness of the binary tree, right? So a complete binary tree can be defined as, so each node should have a child except the leaf nodes. So here we have child for each and every node, right? Except the leaf node. Then the node should start from as left as possible, right? It should be filled from as far as left as possible. So in this case, here we have 4 and 5. So when filling 3, here it has been filled from left. First, the left side has been filled of node 3, right? So the left side should not be null when you have the right part. So what I mean by that? So for example, if I have 6 like this, then this case is wrong. This is not a complete binary tree. Since the left is null, but the right has been filled of the node 3. So it's a compulsory that it should be filled from the left side first, then it should be filled in the right, or the right can be null, but the left side should be filled compulsorily. Otherwise, it can be a leaf node, right? So now we will see how we are going to do this. So first I will show you guys with the success case, then I will show you guys with the failure case, right? So initially I will be having a queue which is filled with the root node 1 in this case, and I will be having a variable flag which is initialized as false at the start, right? So initially I will pop the top element from the queue, that is 1. So I will pop 1 and I will check whether this particular node is none. It's not none, right? So I will append the left and right of 1, that is 2 and 3, right? Then I will pop 2 now. So whether I will check it is none or not. No, it's not none. So I will append left and right of 2, that is 4 and 5, right? So I will append 4 and 5 in my queue. Next I will pop 3, right? Then I will append the left and right of 3, that is 6 and none. The left is 6 and right is none, right? Then I'm going to pop 4, where left and right of 4 is none. I will append that to my queue. Again I will pop 5. I'm going to get none again. So I will append 2 nuns, that is left and right, right? Then I will pop 6, which is again left and right or none. I will append that to my queue. So now again I'm going to pop the next top element, that is none here. So when I detect none, I'm going to set my flag as true and I will continue popping my queue. So again I'm going to get none. I will just keep my flag as true. Then I will just pop every element from my queue until my queue gets empty. If my queue gets empty, then we have a complete binary tree, right? Now I will show you guys the failure case where we will see the effectiveness of this flag, right? So now I have a failure case where the left is not filled but right of 3 is filled, right? So now initially I'm going to pop the node 3 from my queue. Now I will append the left and right of 3. Left is none and right is 6, right? Then I will pop 4 and 5. I'm going to get none. None for 4 and none for 5. So next I'm going to pop the next element from my queue, that is none. So whenever I detect none, I will set my flag as true, right? Then I will just continue. rather than appending any left and right, I will just continue when I detect none. Then I will pop the next element, that is 6 now. Now, I will write a condition within the loop itself. If my flag is true, which means I've seen a empty left before my 6, right? Then I will return false directly. I will not run all these things. I will just return directly false, right? So before we popped the 6, there was none, right? Which means we have seen a left. That is what we are setting here true. Then we are popping the next element from the queue, that is 6, which indicates that I have seen a left that is empty of a particular node. Then I'm seeing a right has been filled for the same node. It is an indication. The flag is nothing but an indication that left of 3 is none, right? Then we are checking if there is any node in my right. If there is a node in my right, then I'm going to return false. Since my flag is true, I'm going to return false, right? That's all the logic is. Now we will see the code. So before we code, if you guys haven't subscribed to my channel, please like and subscribe. This will motivate me to upload more videos in future. And also check out my previous videos and keep supporting, guys. So initially I'm going to have an edge case. If my root is none, I'm just going to return true, right? Then I'm going to have a queue. Initially it will be the root node. Then I'm going to write a while loop until my queue is empty. Then I'm going to pop the node, the top node from my queue, right? Also, I will be having a flag variable which is initialized as false at the start. So now I will check if my node is none, right? If the node is none, my flag will be true. I will set my flag as true. I'll just continue popping my queue, right? Then if I detect true in my flag within the loop, then I will just return false directly, right? So if I have a valid case, I'm just going to append my left and right of my node, right? Then if I am done with the queue, then I will just return true directly. That's all the code is. Now let's run the code. As you guys see, it's pretty much efficient. So the time complexity is order of n and space is order of n as well. Thank you guys for watching this video. Please like, share and subscribe. This will motivate me to upload more videos in future. And also check out my previous videos. Keep supporting. Happy learning. Cheers guys.